Good morning, investors. Yes, we're back for a new year with calculus. And like the Eagles, we'll be taking it to the limit, which is really bad humor. But that's what we get in this class. Ryan, are we going to be able to handle the bad humor? There we go. That's how it starts. Alrighty. So you're going to see some definitions. This is a definition that is not in the book. It's my definition. Okay? And so if you take a look, the example I'm going to give is I drove a lot on 94 McKenna this summer. Okay? I drove to Winnipeg, I think, 7 times. That might be an exaggeration, maybe only 4. But it has a limit on 94. Do you know what the speed limit is? At least in Minnesota. Do you know what the speed limit is? It's 70. Okay? What does that mean to you? Because 70 is correct. What does a speed limit of 70 mean to you? What? That's supposedly as fast as you can go. Do you think that's true? Have you ever driven on 94? Have you ever driven 70? What have you noticed when you've driven 70? Oh, people are passing you like crazy, okay? And every once in a while, you see somebody pulled over because they exceeded whatever that police officer's limit was, correct? Does everybody understand? Like 150 probably was like too much, right? But 75, I can attest to, was okay, right? So my informal definition of a limit, and we're going to talk about limits in terms of functions and graphs. And to begin with, a graph, okay? So I'm going to draw a coordinate system, and I'm just going to pick some type of graph, and I'm going to call this graph f of x. That means it's some type of function, correct? Now, in Desmos, they use the letter A when you do the Desmos activity. Isn't that right, Ryan? I don't like A. It doesn't rank in my top 10 of favorite letters of the alphabet. My favorite letter of the alphabet is C, because it's the third one. Also, Charles, which is my true name, first name, is starts with a C. Yeah. Okay, so this is C is an X value. Because it's on the x-axis, correct? And I'm going to plug in numbers over here. Oh, let me call this x1. Let me call this x2. Let me call this x3. Let me call this x4. Okay? And I'm going to move closer and closer. So if I choose x4 and put it into f of x, I'm going to get a y. Right? F of x is function notation. It tells you 2 things. One, I'm only going to get one y, and it's going to tell me how I'm going to compute that y. Correct? Right? And if I put x3, I'm going to get a different y. And if I put x2 and x1, I'm going to get y's that are going to be like right here. So as I approach C, I'm approaching a y value here. Would you agree? And I could do the same thing over here. I could have a point here, I'll call x5. Right here I got x6. Right here I got x7. Right here I got x8. Here I got x9. And I'm approaching C from the left. Would you agree with that? And it's going to be approaching a y value. Correct? All right. So here's my definition of a limit. We use LIM for limit because we can't, in calculus or math teachers can't spell limit, so we come up with an abbreviation. As x approaches C, some constant from the right, so I use a plus sign, and from the left. And if those numbers are the same, if those y values approach the same number, then the limit as x approaches c from the right and the left. Yep, I will. Is this better? Is that better? Thank you. Then the limit of that function is going to be L. Guess what L stands for? A limit. And it is a y value. And the key word is approaches. I'm going to give you an example. Three. Right here is C. Is that better? So if I approach from the left, I'm going to go here. If I approach from the right, I'm going to go there, correct? Am I approaching, is f, my function, approaching 3 from the left and the right as I get closer to c? It is, isn't it? So 3 is my limit. Now, I'm going to show you the same graph, and there's going to be one little change in it. Here's 3 again, because why wouldn't you choose 3? And I'm going to have a circle right here. You know what that circle represents? There's a hole in the graph, which means there's no y value when I plug c into the function. F of c does not exist. There is no y value for when I put c in here. However, if I approach c from the left and I approach c from the right, again, I'm not at 3, correct? 3 does not give me a value because there's a hole. However, the limit doesn't ask you if there's a value. The limit says, are you approaching? Are you approaching a number? Are you approaching a y value? Am I? Yeah, it's still 3, correct? Even though f of c doesn't exist. Is that making sense? All right, so that's kind of what it looks like graphically. And what we're gonna do here is I've got some tables. And here's my first table. I just did a nice linear one. Okay? And I'm going to put some numbers in here. And I think I already figured out what those numbers are. Let me just... I got a pile of papers, and that's the worst thing in the world for me to have. Yeah. So what I'm going to do is, notice here's 2, correct? And if I plug 2 in there, I get 7. Would you agree? And I'm allowed to put 2 in there, aren't I? Because it's linear. So if I put 1.9 in there and multiply it by 2 and add 1 to it, multiply it by 3, I think I get a value, and I wish I had I think it's 6 point something. What is it? 6.7? You know what this one is? Is it 6.79? 6.97. A little dyslexic. Now look at this. Is this closer to 7 than this one was, we'll finish this tomorrow. Okay? All right, have a pleasant day. Thank you for your patience. And we will, you know what? There might be a little bit more from second period because we're going to be doing the same thing. But we'll start up. Have a great